Imagine Leonardo da Vinci as a young man standing on the banks of a river in Florence, Italy. A bird flies overhead. Most people would simply admire it. Leonardo? Da Vinci looked down at the river and touched it. He noticed something. The rushing of the river was like the rushing of the air as the bird flew by. He grabbed his notebook and jots down. How do birds stay in the air? He starts dissecting bird wings for some reason, and sketches out detailed mechanisms in his notebook. He doesn't just stop at curiosity, he connects biology with mechanics. Fast forward a little, he's sketching what we recognize today as the blueprint for the first helicopter, centuries before it would ever exist. Leonardo recognized something that nobody else had, the relationship between air and water, what we call today fluid dynamics, and it was way ahead of his time. Combining biology with mechanics to realize a novel relationship is definitely genius by anyone's definition. But the world is much larger now than it was during the time of Da Vinci, even Albert Einstein. So, we might ask ourselves, where are all the modern geniuses like Leonardo da Vinci or Einstein today? So what made Da Vinci special? Da Vinci was a painter, hand drawer, and sculptor. But he wasn't just an artist, he excelled in anatomy, engineering, and architecture as well. He took a very mathematical approach to these studies, his art as well, which was interesting because he was a polymath. He taught himself. While Da Vinci was a unique jack-of-all-trades, master of all of them, human knowledge has expanded to a point where it's too large for someone to learn everything all at once. We have to select what we want to specialize in. This was true for Da Vinci too, but the difference is when it comes to discoveries nowadays, the low-hanging fruit have all already been plucked. That's not to say that armchair deduction of new discoveries is impossible, it just generally takes more specialized knowledge to discover something truly novel. While Da Vinci's genius lay in the tangible, sketching mechanical designs centuries ahead of its time, Einstein's brilliance resided in the abstract, developing theories that reshaped our understanding of space and time. As time goes on, even more things that Einstein himself doubted about his own theory have proved true, more than once. Albert Einstein was not a superb mathematician. He was certainly good compared to your average person, but not excellent. In fact, most of his mathematical work and his theory of general relativity was done by his close friend, a mathematician named Marcel Grossmann. However, he was a genius, and many of the foundational conceptual insights were his own. Picture this, you're standing in an elevator, when suddenly the cables snap, and the elevator starts plummeting. It sounds terrifying. But something strange happens. You no longer feel your weight. It feels as if gravity has vanished. Now imagine the same sensation, but instead of falling, you're floating far out in space where there's no gravity at all. Einstein realized that in both cases, free fall and zero gravity, you wouldn't be able to tell the difference. From this, he had a mind-blowing insight. Gravity isn't a force pulling you down, it's the shape of the space around you. Here's the key idea. Heavy objects like planets or stars curve space itself. This is the heart of the theory of general relativity. Gravity isn't just a force, it's geometry. This is the type of thing that someone might imagine, but it would be nearly impossible for your average Joe to just conceive of this from their armchair. It took a special mind with specialized knowledge. But we have tons of people with specialized knowledge today. Where are all the Einsteins? The answer is that they're still around. We live in the age of AI, CRISPR, and quantum computing. All of these were built off of the back of many small but genius discoveries that eventually led to this point. Many of the discoverers were geniuses. They saw what others did not see. But none of these discoveries shifted the paradigm in the way that figures like Da Vinci or Einstein or even Charles Darwin. But the truth is, scientific progress is slow. It tends to be more about meticulously combing over data than it is about the armchair eureka moments that will change everything. Though both do happen. While we do still have geniuses roaming, those skeptical might rightfully ask where the great scientific revolutionizers are at today, then. We do have revolutions, though infrequently. There's Moore's Law, for example, which we're rapidly approaching the end of. The reduced size of microchips in our lifetime is actually insane if you think about it. This is a feat of engineering that can undoubtedly be called a revolution. And life has certainly changed dramatically since the proliferation of the modern cell phone as one of many examples. And I could go on about examples of paradigm-shifting technologies and ideas, but the truth is that these revolutions are generally highly compartmentalized, meaning they happen at different rates in different fields. Psychology is soft science. There are literally dozens of revolutionary psychological thinkers. Archaeology is kind of a hard science, though sometimes it tends to be more soft. It depends on who was in charge, what their work was, what the methodology was, and how, let's say, interpretive the final paper was. Chemistry is a pretty hard science. Notably, there are often discoveries in chemistry. Chemical and pharmaceutical companies invest millions on making them. Every so often, someone creates a radioactive new element that decays away in less than a second, which is impressive, but fundamentally these new elements have already been theoretically predicted long before they were ever created. The only reason people don't just out and make them is because it's typically difficult and expensive to do so. All of these discoveries certainly change how we view the world in their own way. But at the end of the day, it's hard to imagine something that would make the periodic table obsolete, other than something that somehow included a periodic table. Physics is probably the hardest science, and we've gotten to a point that physics discoveries are pretty rare in a purely academic sense. It's true, over the past 100 years since Einstein, there really haven't been any huge revolutions in fundamental physics. We're looking now to discover new particles, like the particle of the Higgs field, but this is unimaginably expensive. Other than that, we've just proven Einstein right a bunch of times, I guess. Physics has another problem. That relativity, the theory that best describes things that have a lot of mass, is incompatible with quantum mechanics. Quantum mechanics is a quantized statistical model. Relativity is a geometric deterministic theory, full of continuous curves. Not to mention the fact that we haven't ever found the graviton particle. The two theories just don't quite work together, which suggests that we do need a paradigm-shifting discovery in physics to resolve this incompatibility. But where is the discoverer? Who knows how many Einsteins we've had that couldn't afford to go to college, pursued different interests and careers, etc. Our current societal system places a monetary barrier on higher education. If the right person has the luck of having the opportunity to pursue that, and if society has the luck to have the right person with the right interests, then discoveries are made. It's a bad system, but it does have one advantage, and that is being better than the alternative. What's the alternative? aptitude tests where we top down tell people what life they can pursue? Where's the freedom in that? So, we should probably keep the system we have, though some improvements could be warranted. For example, if we were able to make higher education more affordable, this could accelerate us towards the next fundamental scientific revolution. We also could do better as a society at inspiring people to get more interested in science. But, what do you think? I want to know your thoughts. Let me know in the comments. Oh, and a quick announcement. I'm going to try and spend a little bit more time on my next video, so it's going to be a little bit before it comes out. So make sure you subscribe to stay up to date, and let me know if y'all have any other video ideas. I can't promise I'll get to all of them, but I'm curious to hear your